So actually today we talk about a couple people, and we decided this time we are doing the unconference style. And so I briefly, and I invited people here, many experts here. I invited 2 people. We have the Google have the this time for the KubeCon, and we announced the gvisor open source. So I invited the 2 experts from the gvisor team, Aiden, and sorry I never pronounced your name for a while. Can you help me? From Brussels, yes. And they are the expert, and they are the inventor of the gvisor. So, and we also invited Xu from the Hyper company, and he is a part of the tech committee of the Kata container. We also invited Steven, and from the Docker, he is the leading engineer working on the container D. So both container D and the CRYL in this year is in the production stage. So if you have the question, and we start to talk about how to make sure those sandbox solution integrate with those container runtime at the OCI level and the container runtime level. So then we can have the very easy seamless of the user experience for our customer. So basically we try to have the single container runtime for your cluster, but you can support and run the Windows application. You can support have the secure part available for some untrusted code. So I invited those customers. Unfortunately, we don't have like the representative from the CRYL because there's the time conflict, schedule conflict from the OpenShift summit next week. And I also invited our leading engineer from the SIG node and the UG and talk about the CRI, talk about the node conform test and the CRI test policy. So help us in the future to choose what kind of the container runtime you want and what kind of actual feature you enable through those tests. So for users, they can easy to using those kind of things. And another thing I invited Lee, which it is leading of the effort on the debug part. And I think last KubeCon, I announced the focus for SIG node. It is 2 focus. One, it is security. So another one, it is the introspection, debugability to help the user. So to what happened on the node, what happened to the Kubernetes, what happened to your pod. So actually, the Lee's work can help us on that area. So this is always the unconference, and if you have any concern and talk, and if there's nobody to talk, and I will invite those expertise on stage and give you brief summary what we are doing and the roadmap, what's the plan here. Okay. Looks like everyone wants just heard what they're doing here. Okay, so, oh. Yes. 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 So it is the right forum to talk about this one. SIG node, at least it is right. And then SIG node also sponsored the resource management work group to discuss those questions. And IO limit, IO control, IO bandwidth, actually it is one of the topics we discussed there. And it's just prioritized, yes. And there's the several proposals we have been reviewed. But none of the proposals right now, it is prioritized to be available. Yes, we are working on those things. Yes. Any more questions? Okay, then I hand over to the Yuji, talk about the CRI, the CRI benchmark, and also the node conform test.
Hi everyone. We started CRI back in I think 2015, and now it's right now it's getting mature. We have different implementations that are production ready. Cryo, for example, I think is right now GA in OpenShift. And Containerd right now, the latest version 1.1 supports a CRI plugin natively, so you can use it out of the box. And there are other implementation too, like FragT, and which deals with more hypervisor-based runtimes. There are other challenges because supporting by hypervisor-based runtime is not just a CRI level stuff. We need Kubernetes API level changes as well, and more changes in Kubernetes overall. And in 1.9, we actually deprecated Kubernetes, the old Rocket integration. I think I've seen people mention in the talks that this is still available, which is not true. It was deprecated in 1.9, and in 1.10, we actually removed all the code. So all the pre-CRI integrations are gone. So right now, we have the Intri, Docker Shim, and different implementations in other repositories. And as for the API, in the past few releases, we were trying to wrap up and tying up some loose ends. Mostly, we work on stats, log stats, and a lot of log stuff. We finished the log format to actually support partial lines, and we are working on getting Fluentd to support this natively, and we actually have the log rotation in kubelet in alpha in 1.10, and we are trying to graduate to beta in 1.11. Apart from that, we are working on the conformance testing. So basically, we want to leverage the node conformance test. I don't know how many people are familiar with the node E2E test. It's kind of in a weird place because we do use it a lot in pre-submit tests and also all kinds of CI testing jobs. But the tests are, some of the tests are shared with the Kubernetes cluster test, some are not, and few of them are actually marked conformance. So no one is actually just running the conformance test suite for Node. We have one test job is failing. So one of the goal for this work is to recategorize all the tests so that we have a conformance test suite. And we can have all the different CRI implementations just publish their test results in the dashboard. And we can see like whether they are passing all the conformance test suites and what optional features they actually support. So it'll be easy for users to track for each release what the runtimes actually support and whether they are passing or not. We have a CRI testing policy in proposal already merged, I think in the community repository. You can take a look if you like, but the actual work is still in progress because of the weird structure we have right now, and some of the tests in the Node E2E suite are part of the Kubernetes conformance test, which now has a more strict guideline and requirements. So as part of this work, we would like to move on and by having a set of node exclusive test tags so that we can sort of evolve the node conformance test independently from the Kubernetes conformance test until we are sure what we actually want to include and what this conformance test actually means. And those are open questions. So like, what does the node conformance test suite should include? And also, how is it different from the Kubernetes conformance test suite? Should they be included as part of it? Should they be different? For example, we have a lot of tests that rely on direct access to the host file system. And those are not, I think are strictly excluded from the Kubernetes conformance test. But those are useful tests for us. If we exclude all of them or if we spend so much time to convert them, we may not make enough progress for qualifying our CRI runtimes. So the proposal right now is work on this for the long term, but also have a workaround so that we can have a different conformance test suite from Kubernetes. Sorry. And the next thing is we have a CRI tools repository, which we have a CRI validation test suite, and also a CRI control, quiet control, which is a CLI tool, command line tool for all the CRI runtimes. And I think we are trying to improve the UI of the query control, and I encourage everyone to try it out and give us feedback. And at the same time, we'll try to remove all the direct Docker CLI usage in the Kubernetes repository and try to replace them with the query control. So if you can help us and give us feedback, that would be great. I think that's about it. So no, it's the node level conformance test, but we want to leverage for CRI runtimes as well. So instead of having a separate CRI conformance test suite, we want to clean up the node conformance test suite and just make it standard for everyone to run and publish results.
So it's kind of a superset of the CRI components?
Yes, and it's testing at the kubelet level, not at the node level, not just interacting with the runtime directly.
And what other kinds of things would it include beyond the CRI?
It tests, for example, create a pod, but that includes kubelet getting the request and actually executing everything, including calling the CRI runtime. Yeah, it includes the kubelet, the underlying OS, the runtime, and everything.
I'm sort of wondering if it's like networking plugins or how that stuff is together.
There are very limited networking tests right now in Node E2E tests due to the nature of it's a single node. And so for that regard, and also because we don't actually define networking in the CRI, so you will have to run cluster E2E to actually test and verify your networking setup.
So next one, we invited Steven give like the updated status of the CI container, which is actually it is the container. So in Q1, Q2, container have the 1.1 release, and the major effort we did is merge CI container into the container. So container itself to natively support the CI interface. So actually, he just showed you the conform test to help to validate the container effort.
Yeah, well, what she said. So, yeah, so I'm going to show you around the node end-to-end tests a little bit. And you can see here we're passing, I guess there was a timeout here. That's red. But you can go through here and look at the various running, and we can see here's the containerd running tests and stuff like that. So is there anything you want me to show specifically in here? Okay. What am I?
So these are the actual like Node E2E test suites and cluster E2E test suites, and the part of the effort is try to formalize this so you don't have to run all the suites here, and it will be easier to track what features you support. So once that is actually done, this will be much easier, and you don't have to run 10 tests for your runtime.
Yeah, and I can show you a little bit about what's going on here. I have some problems because of Wi-Fi, and so things are crashing a little bit. But you can see here's the pods that are running, and I've set up Calico and Kube API server. But CryCuddle is working here as well. Can you see that okay, or should I make that bigger? And let me run CryCuddle so you can see that there's actual. Here's the pods directly kind of from the containerd socket, and then we can actually run the CTR command, and we can see the individual containers that are all kind of all the way working through. Containerd is namespaced. So you can see here we have the pause containers, and then like DNS cube, DNS sidecar, kube proxy, kube controllers, all the way through. Do we want to go deeper? Is this of any interest? Okay, so for instance, here's like the kube scheduler, so we can take that container inside a containerd, and we can look at it, and we can see both the like CRI pod config as well as the run C spec within containerd. I'll show you that really quick. So this is just going to dump the API from the gRPC API, and this looks pretty foreign, but all it is the representation of containers in containerd, and so I can pull out the run C-spec that's actually running that pod. So we can see the exact run C-spec that's going on with that, all with tools that are available in the open source projects. And then there's also this feature called extensions in containerd. So the CRI integration with containerd is storing everything natively in containerd. So we can pull out that extensions field. Hopefully I can get the syntax correct. So here is the actual, I don't know what the exact terminology for this, but it's basically the pod configuration. Is that? Oh, it says it right here. There should be a type somewhere. But you can see here's the ID, here's the actual pod name, and then we can see the sandbox ID, as well as so we can see that there's a kube scheduler. Here's the actual commands running. So with a containerd runtime, like you have really good debugability. So you can go all the way down. You can see the run C specs. You can see the bundles, and everything's kind of available for you. This gets stored in a BoltDB metadatabase directly inside of containerd's main storage engine. You want me to show you where? Like I can, yeah. We can probably find the bytes on disk. You can see it's just a BoltDB database, and I'll do a strings, and then we can grep and see if we can find it. So yeah, so it's just a binary database, but you can see by finding that by running strings on it, and then you can grep the record direct. I don't know why you'd want to do that, but it's there. Is there any other questions? Oh yeah, so 1.2, so right now, the biggest thing that they're working on is Windows support, and there's definitely PRs coming through. I saw that they updated HCS shim the other day, but the best, if you want to know what's going on in containerd, there's two avenues. There's the milestones in the actual project, and you can come here, and they should put a milestone link on the front page on GitHub if anybody from GitHub is here. So you can see here's the 1.2 milestone. There's two things actually. So there's going to be a restart manager so that like you can restart containers in containerd and control that. We experimented with having that outside of containerd, and we found it would be better there. I don't know how much that'll affect the Kubernetes CRI stuff. But the other thing is Windows support. So I think they're working on the layering file system, and then there's also work on rootless containers as well. Lots of the other big thing is being able to have multiple runtimes next to each other, so that like you can run Kata containers and like run C containers and hopefully gvisor containers all next to each other. So yeah, if there's anything you want to see in 1.2, it's really easy to engage with the team by either you can file an issue and maybe request it, or you can directly engage the team through the Docker community Slack. And I'm also available on Signode as Stevo. Let's see if the spelling is. And we can like make that really big. Let's see. Yeah, so if you want to get in touch with me, it's right here. Oh, there it goes. Yeah, it's STEVVOOE, and you can get in touch with me on the Kubernetes Slack or the Docker community Slack if you have questions.
Thanks, Stephen. And actually, Stephen not just show this container D, and also show us a powerful tool, which is built also led by the SIG node. Sorry, you have a question? Oh, okay, so is the CRI, CRI Cattle. So we build this kind of things because we have like a CRI API project, and then we want to make the runtime in the future runtime. It is the CRI compliant runtime. So there's a lot of effort there, and the people most concerned it is usability because everyone get used to Docker client, Docker CLI, and so a lot of concern about those kind of things. So when we start off the CLI project, we start this CLI project. So it is portable. So it is even, unfortunately, we don't have the CRI folks here. So actually the same tools can work with the CRI. So another thing it is now let's invite the Xu to talk about the Fracty and talk about the runway.
Thanks, Don. Hi, everyone. Sorry, I don't prepare this presentation. And firstly, I will introduce something about our work on the Kata containers. And the Kata containers, last year in Austin, the Intel and Hyper announced the Kata containers project that for the virtualized container based on the original work by Intel Clear Containers and Hyper-V. And right now we will release the 1.0 in this month, maybe two weeks later. And the Kata containers now, the design goal, one of the design goal is to work with the Kubernetes seamlessly. So we have prepared some integration with the Kubernetes itself. First one is to use the existing CRI and the containerd, and we will because the Kata containers will provide a runC compatible interface to the command line interface, so we can use them with the multi-runtime support of the containerd and the CRI to support use the Kata containers as a runtime for the privileged part. So for the isolation, and at the meanwhile, the Fracty itself support the runV for the as before, and we also ship all the runV APIs to the Kata containers 1.0, and the work is working in progress and will be finished before the 1.0 release. So as a result, we will shift the Fracty itself to support the Kata containers APIs, and which semantics is compatible with the original runV API and also support the CRI semantics. So this is another way for the Kata containers support in the Kubernetes, and both the way will be available for the 1.0 of the Kata containers. And in the long run, we will think about we will move the Fracty code to several plugins for the containerd itself, and let share some basic code, basic schedule, basic process in the containerd, and could request to the runtime API of Kata containers more efficiently, and that's part of the job. That's the following work for the Fracty, and And also we will have some work on the other parts, such as the CRIs we are talking about to support more efficient way for the CNI. Right now for the kata containers, and also for previous clear container and runv, also in the Fracti, we use a bridge for that. Any of the networking support set up by existing CNI plugins will be use a bridge to set up another link from the NetNS to the VM itself. But by this way, that's less efficiency. So, and in the public or in the production usage, we also use our own CNI plugins to plug the network from the bridge and directly to the VMs. That makes the way simpler, but we need to have some communication with the CNI community to ensure more compatibility with other CNI plugins. And another thing is about the storage. We also have a discussion with the CI community and have some meetings and set up some issues that we could. The way is to try to introduce a detached way to the storage that don't need to for the CI volumes. We don't need to attach all the volumes to mount them in the host by some means. For the networking storage such as NFS and some distributed storage, we could just attach them to the kata containers and the container itself as a device of the VM or as a NFS volume for the VM. Not need to mount them in the host. That's some magic in the CI part, and it's will be a quite small change for the CI. So the upstream community is pretty welcome for the improvement. And usually just mentioned the log part, because all the existing katas will share the same log architecture with the runc and Dockers and so on. So we could share the same log interface. Yeah. So and we are improving on the tests. So that's all. Thank you.
Thanks, Sri. And the next one, I think that we need to talk about a new project and the debugability and also the gvisor. And which one you guys want to talk more first? Okay, yeah.
Hi everyone. I'm Lee, and I'm a SRE at Google. A couple of years ago, we started looking at, from an SRE perspective, running some of our internal applications on Kubernetes, and we had a little bit of trouble at first. It's because we like to use immutable container images and minimal builds and reproducible builds. And when we started doing that with Kubernetes, we were building container images from scratch, and if we made simple mistakes and just volume mounts or mount paths, we had trouble debugging them, so we'd have to go build a debug build that included shells and things like that. So I thought that maybe we could add some features to make that a little easier. So I started working with SIG Node on two different features. So the first one is process namespace sharing. Pods share a lot of resources, but traditionally they don't share the process namespace. So you can't see processes in two different containers across the container boundary in a pod. So that one's a pretty simple change, and it's a feature that's in alpha right now in the current release. And then the more complicated change is something that we call debug containers. And so this is the ability to run a new container, a container image full of debug tools, or really whatever you want, inside of an existing running pod. So this makes it super easy to have a pod that's really just has nothing but your binaries. And then if something goes wrong, you can use a debug container in the running pod to take, maybe you have some automated tools that run and take a snapshot of everything, and or maybe you run a shell so that you can start actually looking at your mount paths. And then ideally we'll then kill the pod afterwards, because we don't want a pod that's been tampered with. So that feature is, there's a couple PRs open right now. So I'm hoping that we can have an alpha in a couple of releases. And that's about it for those features. Does anyone have any questions? No? Okay. Oh.
Yeah, how alpha is the process namespace sharing? Do you use it into
So it was alpha in the release, oh yeah, sorry. How alpha is the process namespace sharing. So when I say alpha, it's a feature flag, it's a feature gate, and it's classified as alpha, so it's not enabled anywhere by default. I use it. I don't use it in production. I don't have any workloads that need that right now. I am looking for feedback if anyone here is using it, or if anyone knows anyone. No? Oh well. So the question was, can we? Let me make sure I got it right. But can we use debug containers to take a core dump? Yeah, that's one of the exact same things that we would like to see, right? So when you're having a problem, you can run a debug container that can see your process and can take an automated core dump and maybe put it in storage somewhere and then kill the pod, and then you can debug it later at your convenience. So process namespace sharing, we're targeting a beta in maybe 1.12. Okay, any other questions? Cool. So my GitHub is verb. I'd love to hear feedback from anyone that uses these features, or if you have any requirements, just let me know. We can have a chat. Thanks.
Next time is Aiden.
Sure. Hi all. So I'm going to talk just for a few minutes about gvisor, then I'm happy to answer questions. We're pretty new to the whole Kubernetes space, and the project just launched on Wednesday. It seems like there's been a lot of interest in it, so we're kind of trying to keep up with some of the developments. So we have a runtime, an OCI runtime that basically sandboxes workloads. Like the Kata folks, we're really interested in providing better container isolation overall, but our target is more for high density, lightweight services, right? There's lots of times we want to run things, they're not maybe first party services that you've authored or whatever, and we want to make that really simple. And so we're really interested in the evolving sandbox pod spec, which I think there's a session going on about that right now. We're really interested in understanding things that Shu was talking about, like for volumes and I guess network-based volumes, these kinds of things, maybe communicating that through the CRI in a bit more of a rich way and seeing how the CRI specification evolves itself. I'm happy to get into technical details about gvisor if people are interested, but I don't want to hijack a node session to do that. I'm the last one? Okay. Okay. So gvisor is a user space kernel effectively. It implements a lot of the Linux system surface. It has this notion of a platform which it needs to intercept system calls or basically run some application. There are two platforms. The ptrace platform, which works a lot like UML for people who are familiar with UML, sort of classic. So it uses sysemu to run things. And the KVM platform, which uses hardware virtualization features. So it doesn't incur such a heavy cost for doing all that interception. Everything happens in user space, so it's sort of emulating what the system surface looks like to applications. It's not exposing any of the host kernel details. The user space kernel does run on top of the host kernel, though, and the reason it's a re-implementation versus something like UML, the big difference is that it's aware that it's a user space kernel, and it's not actually providing like a fixed resource footprint for these applications. So if you have an application that needs 10 megs of memory, you're running in gvisor, it'll use 10 megs of memory plus some amount, like 10 megs on top for the actual runtime. So that's the idea. Really excited at the reception it's had. I can talk in detail about the KVM platform as well, if people are interested in that. But I don't know how deep I should go. Yeah.
I'm interested in how you test gvisor.
What was that word that you used? Test. Oh, that's a strange word. I mean, so we've been using it internally at Google. We have a bunch of tests. The whole open source thing is very new to us, like less than 48 hours old. So, hopefully we'll be able to push some of that stuff and evolve the project a bit faster. We saw there was a lot of exciting developments in this space, and the whole goal is that we want to participate actively and be able to talk about this stuff more openly. So that's why the code is out there now. But on the test front, obviously, what's there doesn't have a tremendous amount of tests. So looking to correct that. So the sort of boundary, the abstraction layer for gvisor is file-based, fundamentally. So we're using the host file system, right? When an application in the sandbox tries to open something, there'll be some validation that occurs and it'll go to the secondary process, but it'll ultimately open something on the local host. So in a traditional kind of VM model, it can be a little bit more challenging. You have to introduce some paravirtualized device or something like an IP device there. But you typically have like a block device that you're connecting to the VM. We don't have that. Anything else I can speak to in detail? Yeah. Sure. So the question is, what's the overhead for networking? The network stack that's implemented, right? So one of the design principles that we're applying here is that we really want to isolate everything we can from the host, and we're starting from sort of a security standpoint first, and then optimizing from there. And so the network stack that is in the sandbox, is not that performant, right? If you're looking at throughput, it's not going to be anywhere near what you get with native. And then depending on the platform choice, there can be pretty high overheads there as well. There is a mode, like if you go look at the repository, where you can pass through some parts of the host networking stack, so you can use some native sockets. A lot of the networking overhead, not the platform overhead, disappears when you do that, but you're making a trade-off there, right? And I think that's a big part of gvisor as well, is that a lot of these different technologies have trade-offs associated with them, right? You're paying some cost for some amount of isolation, and depending on what your workload is, depending on what your requirements are, you're willing to pay different costs. Yeah? So step one is you wait more than 48 hours from the open source launch. The best way to switch production workloads to gvisor. It's a complicated question, so let's just talk about it after. Yeah. The instructions are on the README. Just go that, press the button, go. Or should I? How much time do we have left? Okay, I'll let you wrap it up.
Thank you, everyone, for coming. And if you have more questions, and you already know all the expertise, and find them at lunchtime. And okay, see you next time at SIG Node virtual conference. Thanks.